Chapter 5 covers sampling, and we'll focus on sample planning, sampling methods, and sampling distributions. Basically, when we conduct research, we're selecting a subset of elements or a sample from the entire group we're interested in or the population. Think about political polls that you may see that 600 people are randomly selected from the population of the United States. So the population of the United States is what we're interested in, really, and we'd like to be able to generalize those findings from our sample. But what's real important is how that sample was generated or selected. If we have a random sample, we have a much greater chance of being more in line with what's really going on in the population than if we had some type of biased selection. But interesting enough, we'll find that there's procedures that can be used to determine how large a sample size we need, and this is often very important in studies because it has a lot to do with money, especially if you're calling people or conducting interviews. And there's methods of finding out how many subjects you need. I'm not going to get into all those details. Some of it's related to statistical procedures that are taught in stat courses. But here's a book by Kramer and Blasey. It's a classic, but it's just the second edition. It's called How Many Subjects? Statistical Power Analysis in Research. And this is, of course, the book that we all refer to before a lot of the online programs were available. Statistical Power Analysis for the Behavioral Sciences, second edition by Jacob Cohn. And of course, there's tables after tables, and you look up various features that relate to your study to see how many subjects you would actually need. So we select a sample to understand what's going on in the population. I mean, in the ideal situation, we'd be able to select our population, right? But that's not very, very likely in conducting large-scale research just due to the time and cost constraints. So we select a sample. And we often have a sampling frame or a list from which the elements of the population are selected, and then that leads to our sampling unit, any single unit sampled from the population. But how do we how do we generate samples? How do we create samples? And that's what we'll be focusing on. But one of the things we want to see is if we can generalize from a sample to the larger population. And this is, of course, relevant to the type of sampling that you would do. So many times what we'd like is a representative sample, so it looks like the population and has similar characteristics. Sometimes we have an unrepresentative sample where certain groups or characteristics are over or under represented, leading to bias. And we're always going to have some sampling error in conducting our research, and we do certain things to try to minimize. The two basic types of sampling methods are probability and non-probability sampling. And probability sampling allows researchers to get subjects that are statistically representative of the population that is of interest to the researcher. And there's different types of probability sampling discussed in your book, and the major types are simple random sampling, systematic random sampling, cluster sampling, and stratified random sampling. Now, simple random sampling is basically what it sounds like. That we select randomly from a list, let's say a certain number of items or people, and that becomes our sample. So if you think about, if I wanted to conduct a random sample of the class, I could go ahead and print out, an Excel spreadsheet of everyone, and then ask Excel basically to randomly select a certain number of people. So it may select a second one, the fifth one, the ninth student, the 11th student, and so on. But the whole idea is everyone has the same chance of being in the sample. Systematic random sampling is where we have a list and every nth element is selected. I used systematic random sampling when I worked for a large organization. We were doing a lot of research, and we had some samples that might have 10,000 people, and we wanted to do some surveys, and we'd send out maybe 400 surveys, and we might use we used systematic random sampling often, where depending on how many we'd want to send out, we'd randomly select a starting point. Like let's say we get on the 10th person, and then from there on, that we would have a program that would select every 75th person or every 50th person, or whatever the case might be, to get the desired number that you want. But you got to make sure that there's not some type of ordering in that list that's going to lead to problems. And that's periodicity, which is where there's a particular pattern, and that can bias the results. We didn't have to worry about that. It was basically the names were alphabetized, and so there's no reason to believe those that have their last name beginning with A are significantly different with those with B's, C's, D's, and so on. There is a situation where random sampling was done, and it was systematic random sampling, and I looked at it and realized that the big problem, it was on traffic patterns that seemed to be present, was that that they somehow missed the times of the day when there was major traffic. So it seemed like there was much less traffic. And, of course, the problem would be that if they only sampled those times where there was a lot of traffic, that would be a bias as well. So you have to look into these scenarios, and that's the sampling error. You're missing something, or sampling bias, where you're only selecting a certain scenario. Stratified random sampling uses information known about the total population of interest prior to sampling, and it makes the sampling process more efficient. With stratified sampling, you're basically creating the groups. So that you would go ahead. For example, let's say you were looking at police departments, and you wanted to conduct a study based on gender, age, race, and ethnicity. You might go ahead and create groups to randomly select from based on gender, race, or ethnicity, or age categories. So sometimes you would do that, and that can be helpful. And other times you might use cluster sampling, where you usually start with naturally occurring groups that you might, for example, start looking at the United States prison population, and then you randomly select a number of prisons, and those might become your clusters, and then you can select from those prisons. You can go ahead and you can move into other sampling procedures. So the idea of multi-stage cluster sampling is to maximize the number of clusters selected and minimize the number of individuals within each cluster. And so again, you may find that you randomly select 10 prisons from the United States, and then you move on to, do you maybe you then look at everyone in that prison, in each prison, or maybe use random sampling within each prison. There's also non-probability sampling, where each member of the population has an unknown probability of being selected. And sometimes this occurs when there's a very small population, and obviously random sampling would be uh, problematic. The example I would use is in a hospital setting when we had an interest in studying Munchausen syndrome by proxy. This is a situation where a caregiver, often a parent, would purposely make their child sick to gain attention of the hospital. If we were going to study those cases, I would not take a random sample of everyone who came through the hospital. What I would do basically is I would look for the Munchausen syndrome by proxy cases and look at all of those. That's obviously non-probability sampling procedure. In fact, I'm trying to select the whole population. Obviously, I would miss some if we were going to survey, because those might have not been detected. But the whole idea there is that's the needle in the haystack scenario, where if you do random sample, you end up getting from the haystack, but you miss the needle. And different types are availability, quota, purpose of or judgment, and then the snowball sampling. Availability basically is they're there, and so they're available. That if and so we see that sometimes in exploratory research or in pilot studies. I conducted a study on the effects of a parent support group for parents who had abused children, and I basically used an availability sample, also referred to sometimes as a convenience sample. They were there. Some may use quota sampling, and here that one would sample to try to get characteristics in proportion to their population or quota. But it's kind of similar to stratified probability sampling, but much less precise because of the nature of the sampling procedures. And so even though you have a quota in that sense, you don't know if it's representative. Purpose of sampling is each sample element is selected for a purpose, usually because of a particular uniqueness or characteristic in the population. And then snowball sampling is where we may ask participants to refer us to other facilities or other participants for our study. And this is often useful in hard to reach or hard to identify populations. And you can also see in your book, random sampling error is discussed, and also sampling distributions and systematic sampling error. And so you can see we run into a lot of these issues and problems regarding sampling distributions and errors, and what happens. One thing we often do in surveys, for example, what we should do is report the response rate, and everything else should be reported in studies as well. The sample size, how the sample was collected, any problems with that collection,